Let us discuss another problem here. A sound source S is moving along a straight track with a speed v and is emitting the sound of frequency v naught. An observer is standing at a finite distance at the point O from the track. The time variation of frequency heard by the observer is best represented by T naught represents the instant when the distance between the source and observer is minimum. So here this is a source. This source is moving towards observer. So here this is observer location. This is the source. Source is moving along this direction. So the component of velocity of source along the line joining between the source and observer is what we write here, v cos theta. V cos theta. This is the line of sight between source and observer. So as source is moving along this direction, source is approaching towards observer, then here theta value is, what happens, theta value is increasing. Theta value is increasing. When theta value is increasing, cos theta value is decreasing. Cos theta value is decreasing. For example, the observed frequency heard by the observer n dash is equal to, we write here, nv by v minus v cos theta. So here n is nothing but real frequency, v cos theta is nothing but velocity of the source along the direction, along the line joining between the source and the observer. So when the source is moving towards observer, when it reaches to position 1 to position 2, then what happens, theta increases and cos theta is decreases. Whenever cos theta is decreases, v minus v cos theta is increases. When v minus v cos theta increases, the observed frequency n dash is decreases. The observed frequency n dash is decreases. So among the following graphs, that fourth one is initially frequency is more. Initially your n dash is more. After that it will decreases. So the fourth graph is the correct one. Correct graph is nothing but fourth one here. So when the source reaches to from position 2 to position 3, the source is moving away from the observer. So that what happens, that apparent frequency is decreases with respect to time. Whenever the source is moving away from the observer. So among the options, the best option is option 4. Option 4. Okay. The frequency, see that option 3. Here they given the frequency is constant, but that is not happened here. Option 4. So now let us discuss another problem here. Figure shows the hollow cone, ice cream cone here. If its mass is m, radius of the top is r, and height is h, then its moment of inertia about its axis. So this is a direct formula based question. Moment of inertia of a hollow cone about axis is mr square by 2. This is the formula based question. You have to remember that formula. Okay. Now let us discuss another question from units and dimensions. The density of the solid metal sphere is determined by measuring its mass and its diameter. Okay. The maximum error in the density of the sphere is x by 100%. If the relative error in the measuring mass and the diameter are 6% and 1.5% respectively, then the value of x is here density is equal to, we write here mass by volume. So density is equal to mass by, here volume of the sphere is nothing but 4 by 3 pi r cube. Density is equal to mass by 4 by 3 pi. R is nothing but d by 2 whole cube. Okay, now d by 2 means diameter. So density is equal to mass by 4 by 3 pi d cube by h. So we write the formula here, delta d by t into 100 is equal to, delta d by d into 100 is equal to, what we write here, delta m by m into 100 plus 3 into delta d by d into 100. So this is a given x by 100, that is equal to, here delta m by m, this means 6 plus 3 into, this is 1.5. So x by 100 is equal to, what we write here, so 6 plus 4.5. So here I am going to start here, x by 100 is equal to 10.5. So x is equal to, here 10.5 into 100, that is equal, x is equal to 1050. So our answer is 1050. Now let us discuss another question here. Two bodies of same mass are moving with the same speed but in different directions in a plane. Okay, so the different direction plane, they have a completely inelastic collision and moving together thereafter with a final speed which is half of their initial speed. The angle between initial velocities of the two bodies in degrees. So here this is one body is moving along this direction with velocity v naught, and this is another body is moving along this direction with the velocity v naught. The angle between them is theta. Okay, initial angle between them is theta. So same mass, this mass is m, this mass is m. This body is making an angle theta with the horizontal initial direction. This body is also making an angle theta. Okay, now so after inelastic collision, they are moving with half of the initial velocity. And the total mass is nothing but how much? Total mass is nothing but 2m. Now what they ask here, the angle between initial velocities of the two bodies. The angle between them, initial velocity. So this is the initial velocity of the first body and this is the initial velocity of the second body. After collision, they combined each other and they are moving with half of the initial velocity. So here the initial momentum along x direction, that is equal to here, what here, v naught cos theta along this direction, and v naught cos theta of the second body along this direction. So that the initial momentum is nothing but how much? M into v naught cos theta plus m into v naught cos theta along x direction, that is equal to final momentum, that is equal to 2m into v naught by 2. So here 2m v naught cos theta is equal to 2m v naught by 2. In any type of collision, momentum is conserved. Already we know that. So here 2m gets cancelled, v naught gets cancelled, cos theta is equal to 1 by 2. Theta is equal to 60 degrees. Theta is equal to how much? 60 degrees. So the initial angle between them is equal to 2 theta. This is theta, this is theta. That is equal to 2 into 60 degrees. That is equal to 120 degrees. So our option, that means this is an integer type of question. So answer is 120 degrees. So now let us discuss another question here. Suppose the intensity of a laser is, here laser, intensity of laser I is equal to 315 by pi watt per meter square. The RMS electric field in units of volt per meter associated with the source close to the nearest integer is. So we want to find out what ERMS. ERMS is equal to question mark. So this is NCERT direct problem here. So I is equal to, in electromagnetic waves, this is a NCERT direct problem, epsilon naught C E naught square. That means ERMS square. Okay. So here ERMS square is equal to what we write here, I by epsilon into C. So ERMS is equal to square root of I by epsilon into C. That is equal to intensity of wave is nothing but how much? 315 by here pi epsilon naught. So C means 3 into the power of 8. So here ERMS is equal to now divided denominator and denominator with 4. 315 into what will happen? 4 divided by 4 pi epsilon naught into 3 into 10 to the power of 8. So here ERMS is equal to right, we write here 1 by 4 by epsilon is nothing but what is 9 10 to the power of 9. 3 into 15, 9 into 10 to the power of 9 into 4 divided by 3 into 10 to the power of 8. 3 into 10 to the power of 8. So here ERMS is equal to. So this is 315 into 4, that is 1260 into, this is cancelled 3 times, into 3 into this is nothing but how much here? 10 to the power of 8, 10 to the power of 9. This is cancelled 10 times. So here ERMS is equal to, what we write here? ERMS is equal to 126 into 3 into 100. 126 into 3 into 100. That is equal to here 378 into 10. So square root of 378. That is nearly is equal to 19.44 into 100. That is equal to, here we get 194.4. 194.4. So now we are going to discuss another question. A part of a complete circuit is shown in the figure. At some instant, the value of current I is 1 ampere and it is decreasing at the rate of 10 square ampere per second. The value of the potential difference Vp minus Vq is. So here, this is inductor in the circuit and this is battery 30 volts and this is resistance P and Q. So this is inductor, this is nothing but 50 milliamperes, millihenry. Current is going along this direction. Here the current is decreasing. Current is decreasing at the rate of 10 square ampere per second. That is equal to di by dt is equal to 10 square ampere per second. Current is decreasing. Now we want to find out what Vp minus Vq. Vp minus Vq. So we start here this point Vp, okay. So here positive to negative. So this is inductor. EMF is nothing but L into dA by dt minus 30. Here what is the value of resistance? R is equal to 2 ohms. So how much current it is passing? I is equal to 1 ampere. That is equal to here. We are going opposite to the direction of current. Opposite to the direction of current means 2 into 1. That is equal to Vq. Right. So here Vp minus L means how much? 50 into 10 to the power of minus 3 Henry into dA by dt tan square minus 30 plus 2 is equal to Vq. So here Vp minus this is nothing but how much? 10 square into 10 cube, 5 minus 35 plus 2 is equal to Vq. So Vp minus Vq is equal to how much? Vp minus Vq is equal to 33. So here the current is decreasing. Whenever the current is decreasing in the inductor, it opposes that decreasing current. It opposes the decreasing. Whenever the current is increasing in the conductor. So here, when the current is decreasing in the inductor, the EMF is produced in the inductor. It also produces the current in same direction. That means here, this end becomes positive and this end becomes negative. Okay. So here very important point you have to remember is, so here this is inductor. When the current in the inductor is increasing, then what happens? The EMF is produced in the inductor. The EMF is produced in the inductor. So that EMF produces current in opposite direction. Like this. This end becomes negative and this end becomes positive. And you have to remember another point is, when the current is decreasing in the inductor also produces current, its own current. That means induced EMF is developed. Inductor also produces its own current and in same direction. So here this end becomes negative, this end becomes positive. Okay, this is the direction of current produced by the inductor. So you keep remember these important points. So our answer is Vp minus Vq is equal to 33. Here the current is decreasing. So inductor also producing current in same direction. So that this end becomes negative and this end becomes positive. Right. So now we are going to discuss another problem here. An insect is at the bottom of the hemispherical ditch of radius 1 meter. It crawls up the ditch but starts slipping after it is at a height h from the bottom. If the coefficient of friction between the ground and the insect is 0.75, then h is. So here g is equal to 10 meter per second square. So here this is a hemispherical bowl. The insect crawls from the bottom of the hemispherical bowl and it gradually crawls up to height h. After it reaches to height h, it starts slipping. Okay. Now, up to what height it reaches in the hemispherical bowl. That is, we are going to find out. Okay. So here this is mg. This is nothing but what mg here, and this is normal reaction. This is normal reaction. Okay, and this makes an angle theta, assume that with this line, and also this angle is also theta. This is mg cos theta, and this is a mg sin theta. So whenever it starts slipping, then there is a frictional force is acting along this direction. F is equal to along this direction. Okay. Now here, this is the radius of the ball. Radius of the ball. So now balance the forces here. N is equal to mg cos theta, and the frictional force F is equal to mg sin theta. Mg sin theta. So here, what happens here? So frictional force is nothing but what? Mu into n is equal to mg sin theta. Mu into mg cos theta is equal to mg sin theta. So here tan theta is equal to mu. Tan theta is equal to mu. Tan theta is equal to mu means 0.75 here they given. That is equal to 3 by 4. So this is tan theta. This is 3, 4, 5. Okay. So now this is total is nothing but R. So now we are going to find out a height reached by the crawl. If this angle is theta and this angle is also theta, and this much is nothing but here this is r cos theta, and this total length is r. So this is h is equal to total radius r minus r cos theta. So that is equal to how much here? R into 1 minus cos theta. So 1 into 1 minus cos theta is equal to what now? What we write here? 4 by 5. That is equal to h is equal to 1 by 5. 1 by 5. That is equal to what we write here? 0.2 meters. 0.2 meters. So what is our answer here? Our option is 0.2 meters. Let us discuss another question here. In the figure below, P and Q are two equally intense coherent sources emitting radiation of wavelength lambda is equal to 20 meters. The separation between P and Q is 5 meters. And the phase of P is ahead of Q by 90 degrees. A, B, C are three distant points observation, each equidistant from the midpoint of PQ. Midpoint of PQ, right. The intensity of radiation at A, B, C will be in the ratio. So here at point A, now we are going to calculate a point A. So here the path difference, the two light waves are coming from this P and Q. The path difference between P and Q is nothing but 5 meters. So phase difference due to the path difference, 2 pi by lambda into 5. That is equal to pi by, what is lambda here? So here lambda is nothing but 20 into 5. So that is equal to pi by 2. Pi by 2. So already P is ahead of Q by phase pi by 2. By phase pi by 2. So net phase difference is equal to pi by 2 minus pi by 2. That is equal to how much? 0. So intensity at I is equal to 4 I naught cos square pi by 2. That is equal to 4 I naught. 4 I naught, okay, that is equal to 4 I naught. Right. So here now we are going to find out intensity at point B. At point B. So here two waves are coming from P and Q and reaches to B. There is no path difference between these two waves to reach B. So phase difference is 0. But already in the question they given that P is ahead of 90 than Q. So net phase difference is equal to pi by 2. So here I is equal to 4 I naught cos square pi by 2 by 2, that is equal to pi by 4. So here I is equal to 4 I naught. This is nothing but cos square pi by 4. Cos 1 pi by 4 is 1 by root 2, that is equal to 1 by 2, that is equal to 2 I naught. So here at point C, so the wave which is coming from Q due to the path difference between P and Q is phase difference is equal to 2 pi by lambda into path difference, that is equal to 2 pi by lambda is equal to how much here? Lambda is equal to 20 into 5, that is equal to how much? Pi by 2. That means due to the path difference between P and Q, the wave coming from Q has a phase pi by 2. But the wave coming from P already has a phase pi by 2 ahead of Q. So net phase difference, so net phase pi by 2 plus pi by 2, that is equal to here pi. So I is equal to cos square 4 I naught cos square 5 by 2. Cos square 5 by 2. That is equal to how much here? That is equal to I is equal to 0. I is equal to 0. So now the ratio of intensities IA is to IB is to IC is equal to 4 I naught is to 2 I naught is to 0. That is equal to 2 I naught is to 1 is to 0. 2 is to 1 is to 0. This is the answer. So our option is 2 is to 1 is to 0, that is option 3. So now we are going to discuss another question. If the potential energy between two molecules is U is equal to minus A by r to the power of 6 plus b by r to the power of 12. Then at equilibrium, separation between the molecules and the potential energy are. Separation between the molecules and the potential energy is equal to how much? So at equilibrium, net force is 0. Equilibrium net force is 0. We know that here F is equal to what we write here, minus du by dr, negative gradient of potential energy. So here minus du by dr, that is equal to 0. So differentiate above equation with respect to r. U is equal to what we write here, a by minus a by r to the power of 6 plus b by r to the power of 12. So du by dr is equal to minus 6a by r power 7 plus 12b by r to the power of 13. So here du by dr is equal to 0. Du by dr is equal to 0. Then 6a by r power 7 is equal to 12b by r to the power of 13. R to the power of 13. Right. 6a is equal to 12b by r to the power of 6. R to the power of 6. So here r power 6 is equal to 12b by 6a. That is equal to 2b by a. 2b by a. So here r is equal to what we write here, 2b by a whole power 1 by 6. Whole power 1 by 6. So here the separation between them is r equal to 2b by a whole power 1 by 6. Now the potential energy, substitute this value in this equation. Potential equal to minus a by r power 6 plus b by r to the power of 12. So u is equal to minus a by r power 6. So 2b by a whole power 1 by 6 whole to the power of 6 plus b by r power 12. R power 12 means here r 2b by a whole power 1 by 6 whole power 12. So u is equal to what we write here, minus a square by 2b. Minus a square by 2b plus here what we write here, a square b by 2b square. A square b by 2b square. So u is equal to here minus a square by 2b plus here a square by 2b. For a square by how much here, that is equal to here this is nothing but 4b square, that is equal to here 4b. So 2 square is nothing but 4b square, that is equal to what we get here, u is equal to, this is 4b. So here minus 2a square plus a square, that is equal to minus a square divided by 4b. So this is our answer. So our option is option 3. Option 3. So now let us discuss another question here based on the screw gauge. So in this question here, a screw gauge has 50 divisions on its circular scale. The circular scale is 4 units ahead of pitch scale, marking prior to use. Upon one complete rotation of the circular scale, a displacement of 0.5 millimeter is noticed on the pitch scale. The name of the zero error is involved and the least count of the screw gauge are respectively. So here the pitch scale, the circular scale is 4 units ahead of the pitch scale marking. That means the error is positive error. Positive error. So this is the pitch scale marking and this is circular scale. So circular scale is 4 units ahead of the pitch scale. So error is positive error. Now, upon one complete rotation of the circular scale, a displacement of 0.5 millimeter is noticed on the pitch scale. That means here the given pitch of the screw that is equal to 0.5 millimeter. Now, the least count is pitch of screw divided by number of head scale divisions. That is equal to what here? Pitch of the screw is nothing but 0.5 millimeter by number of head scale division is nothing but 50. So that is equal to here. What we write here? That is equal to here 1 by 100 millimeter. Okay, that is equal to 10 to the power of minus 2 millimeter. So 10 to the power of minus 2 millimeter means here 10 power minus 2 into 10 power minus 3. 10 power minus 3 meters. So here that is equal to 10 micrometer. 10 micrometers. So our option is option 4. Option 4. This is our answer. Now let us discuss another question here. A particle of charge q and mass m is moving with velocity minus vi towards a large screen placed in the yz plane at a distance d. So if there is a magnetic field B equal B0 into K, the minimum value of V for which the particle will not hit the screen. So here this is a screen. This is a charged particle of mass m and charge q. This charged particle is moving along this direction. Okay, this is with velocity minus vi. So whenever this charged particle is moving towards the screen in the magnetic field is along positive k direction. So that force is acting on the charged particle is along this direction. So this charged particle takes a circular path. Of a radius how much here? R. If the radius of this charged particle is more than d, then what happens? This charged particle hit the screen, no doubt at all. So here the minimum value of v which the particle will not hit the screen is. So here the radius of the charged particle must be less than this d. D is the distance of the charge from the screen. If r is greater than d, then this charged particle definitely hit the screen. So that r is less than d. So we know that R is nothing but mv by qb. R is nothing but radius of the charged particle in a circular path less than d. So v is less than qbt by m. Okay, the minimum velocity v minimum is equal to how much here? Q into what is the magnetic field here? B naught d by m. Minimum velocity is this much. If the charger particle is moving with this velocity, it will not hit the screen. It will not hit the screen. Okay, right. So let us discuss another question. Charges Q1 and Q2 are at a points A and B of a right angle triangle OAB. So these are the charges. Charge Q1 is kept at A and charge Q2 is kept at B. This is a right angle triangle OAB. The resultant electric field at a point O is perpendicular to the hypotenuse. Then Q1 by Q2 is proportional to, and this is at a distance x1 and this is a distance x2. The distance of charge from O is x2, and this is due to this charge the electric field is along this direction. This is E2. Due to this charge the electric field is along this direction, that is E1, and this is resultant electric field. This resultant electric field is perpendicular to the hypotenuse, and if this angle is theta, this angle becomes 90 minus theta, and this angle theta, and this angle is also theta. Now in triangle OAB, tan theta is equal to what we write here? Tan theta is equal to x1 by x2, equation 1. So from this is a net electric field. From this tan theta is equal to, we write here, E2 by E1. E2 by E1. So that is equal to K, E2 means KQ2 by x2 square divided by KQ1 by x1 square. E1 is nothing but what? KQ1 divided by x1 square. So here KK cancel. That is equal to what we write here? Q2 by Q1 into x1 square by x2 square. Right. This is equation 2. Equation 2. So equating 1 and 2 equation, x1 by x2 is equal to, this is also tan theta, this is also tan theta, x1 by x2 is equal to q2 by q1 into x1 square by x2 square. So here q1 by q2 is equal to, this x1 is cancelled x1 times, this x2 is cancelled x2 times, x1 by x2, x1 by x2. So this is answer, our answer. So our answer is option 3. Option 3. So now another question let us discuss here. That is another question. A clock has a continuously moving seconds hand of 0.1 meter length. The average acceleration of the tip of the hand in meter per second square is of the order of. So average acceleration is nothing but A is equal to V square by R. So A is equal to, we write V is equal to R square omega square divided by R. V is equal to R omega. So A is equal to here R omega square. R omega square. Here what they given here, R is equal to 0.1 meter. 0.1 meter. So A is equal to 0.1 into omega is nothing but 2 pi by t whole square. So 0.1 into 4 pi square divided by t square. So A is equal to, what we write here, A is equal to 0.1 into 4 into pi square is nearly 10. What is the time period of the seconds hand? 60 seconds. So property 60 into 60. 60 into 60. So A is equal to here 10 to the power of minus 1 into 10 to the power of 1 into here this is 60 into 60, that is 6 into 6 into 10 square. This is 10 to the power of minus 2 into 4 divided by 36. So A is equal to 4 ones are 4 nines are. So 1 by 9 into 10 to the power of 4 here minus 2. So this is equal to 0.11 into 10 to the power of minus 2. That is what we write here, 1.1 into 10 to the power of minus 3 meter per second square. So it is in the order of 10 to the power of minus 3. So our option is option 4. Option 4. Now we are going to discuss another question here. That is sixth question. So sixth question. An electron, a doubly ionized helium and a proton are having same kinetic energy. The relation between their respective de Broglie wavelengths are lambda E, lambda He plus plus and lambda P is. Right. Here we know that the kinetic energy is equal to P square by 2m. Kinetic energy is equal to what? P square by 2m. So P is equal to square root of, we write here, 2m into K. And also de Broglie wavelength lambda is equal to H by P. So here lambda is equal to H by square root of 2m into K. 2m into K. So all are same kinetic energy. H is a constant. So lambda inversely proportional to 1 by root m. 1 by root m. Kinetic energy is constant, H is constant, 2 is constant. So lambda inversely proportional 1 by root m. So the particle which has less mass having more de Broglie wavelength, that is equal to here lambda E is greater than, electron has the least mass, electron has a least mass, so that it has more de Broglie wavelength. After that proton, lambda E is greater than P, that is greater than lambda He plus plus. The helium plus plus, doubly ionized helium has a more mass, so that it has a least wavelength. So our option is option 1. Okay, now we are going to discuss another problem here. 4 point masses, each of mass m, are fixed at the corners of the square of side L. The square is rotating with angular frequency omega about an axis passing through one of the corners of the square and parallel to its diagonal, as shown in figure. The angular moment of the square about the axis. So here this is a square. So we kept 4 masses at the corners of the square. So this square is rotating about this axis. This is axis. Now we want to find out angular momentum. We know that angular momentum is equal to L is equal to I into omega. So L is equal to, here we are going to find out the moment of inertia of all masses. So here moment of inertia for this mass, so that is equal to here m into 0 square plus, why, because this point lies on the axis, and the moment of inertia of this mass, So this is L and this is L. This total distance is nothing but root 2 L. So this is how much here? L by root 2. L by root 2. This distance also L by root 2. Now here m into L by root 2 whole square plus m into L by root 2 whole square plus m into the distance of this mass from the axis is root L, root 2 L whole square. So L is equal to what we get here. This is 0. This is ml square by 2 plus this is ml square by 2 plus this is 2 ml square. So finally we got L is equal to 3 ml square. So what is the moment of inertia here? L is equal to 3 ml square into omega. 3 ml square into omega. So that is option 1. This is our answer. This is our answer. So now we are going to discuss another problem. An object of mass m suspended at the end of the massless wire of length L and area of cross section A. Young modulus of material of the wire is y. If the mass is pulled down slightly, its frequency of oscillation along vertical direction is. Frequency of direction along a vertical oscillations is. So this is a wire. A mass is attached to one end of the wire, that is small m. That is a small m. When it is pulled down, then what happens? It begins to oscillate. It begins to make vertical oscillations. Vertical oscillations, and also there is a restoring force is developed in the wire. That restoring force developed in the wire. Because of that restoring force, it comes into the equilibrium position and it makes vertical oscillations. So we know that here Young modulus is equal to longitudinal stress by longitudinal strain. So here y is equal to stress is nothing but F by A divided by strain is extension by capital L. So here y is equal to what we write here, F into capital by A into small l, right? But here whenever there is a oscillation starts, the restoring force is developed. F is equal to K into L. Small l is nothing but the extension or the extension in the wire. Restoring force F is equal to K into L. So here F is equal to what we write here, y into L by capital L. So equating these equations, y into A by y into A into small l by capital is equal to K into small l. Cancel. So K is equal to ya by L. K is equal to what we write here, ya by L. So we know that frequency of the mass n is equal to 1 by 2 pi square root of K by m. So n is equal to here 1 by 2 pi square root of K is nothing but A by L into small m. So our answer is option 4. Option 4. That is our answer. So now let us discuss another question here. An AC circuit has a resistance how much? Third question. And resistance is nothing but R is equal to 100 ohms. C is equal to 2 microfarads. And L is equal to 80 millihenry. Connectance series. The quality factor of the circuit is. We know that quality factor is equal to L omega by R. Quality factor is equal to how much? L omega by R. But omega is equal to what we write here? 1 by square root of LC. So, quality factor Q is equal to, we write L into 1 by square root of LC divided by R. So, Q is equal to what we write here? 1 by R square root of L by C. 1 by R square root of L by C. So, 1 by, what is the value of R here? 100. What is the value of L here? 80 millihenry. 80 into 10 power minus 3 divided by R. R is equal to 100. So, here that is equal to 1 by 100. So, here C is equal to, we write 2 into 10 to the power of minus 6. 2 into 10 to the power of minus 6. That is not 100. So, 1 by 100, right here, this is 40 into 10 power 3. 10 power 3. 1 by 100 into. This can be written as 4 into 10 to the power of 4. That is equal to 2 into 10 square divided by 100. So, we write here 200 divided by 100. That is equal to 2. So, our answer is quality factor is equal to answer 3. Answer 3. So, we write here 1 by R square root of L by C. L is nothing but 80 millihenry. 80 in 10 to the power of minus 3. C is nothing but 2 in 10 to the power of minus 6. So, on doing the calculation, we get here quality factor is equal to 2. So, now let us discuss another question. A point-like object is placed at a distance of 1 meter from a convex lens. Of focal length 0.5 meters. A plane mirror is placed at a distance of 2 meters behind the lens. The position and nature of the final image formed by the system is. So, this question asked lens and mirror combination method. Here, this is a point object, okay, which is placed at a distance of 1 meter from the convex lens. 1 meter from the convex lens. Right. So, here a focal length, the convex lens focal length is equal to F is equal to 0.5 meters. Okay, now a plane mirror is placed at a distance of 2 meters behind the lens. So, this is a plane mirror. This plane mirror is placed at a distance of 2 meters from the lens. The position and nature of the final image formed by the system. Here, the focal length of convex lens is F is equal to 0.5 meters. That means here the object is kept at 2F. The object is kept at 2F. Then image formed by the lens is also 2F. Okay. So, if this is 1 meter, this image is nothing but I1. This is also 1 meter. That means this image acts as object for the plane mirror, and we see virtual image I2 at same distance. At a same distance inside the mirror. Now this what is the final image formed by the system? Final image formed by the system. Okay, and what the position nature of the final image formed by the system is, right? So this I2 image acts as object for the lens, and the final image formed by the lens we are going to find out. Right here, you know that 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by v minus 1 by u. So f is equal to here 0.5 meters. We want to find out v is equal to question mark, and u is equal to, so this acts as object for the lens. So the light rays are coming from this object along this direction, and this is optic center. So we are measuring opposite to the direction of light rays. So that is, what is the distance here? U is equal to minus 3. Minus 3. This is 1, 1, and this is 1. That is equal to U is equal to minus 3. Now 1 by 0.5 is equal to 1 by V plus 1 by 3. So 1 by V is equal to 1 by 0.5 minus 1 by 3. That is equal to 2 minus 1 by 3. That is equal to here 5 by 3. 5 by 3 means V is equal to here 3 by 5. That is equal to 0.6 meters. 0.6 meter means that is positive. So that is positive means from where? Here I3 image is formed, 0.6 meters. So the position and nature of the final image formed by the system. So this is a real image. This is a real image, and here this is formed at 0.6 meters from the lens. 0.6 meters from the lens. But from the mirror, how much distance it has? 1 plus 1 plus 0.6. So from mirror it is formed 2.6 meters. 2.6 meters. So this is 1, and this is 0.6, 2.6 meters. So our option is answer 4. Answer 4. So see that question. A satellite is an elliptical orbit around a planet P. It is observed that velocity of the satellite when it is farthest from the planet is 6 times less than that when it is closest to the planet. The ratio of distances between the satellite and the planet at the closest and farthest point is. So this is a planet. Around the planet, the satellite is revolving in a elliptical orbit. This is a R1 is a closest distance and R2 is a farthest distance. So here, when the planet is when the satellite is closer to the planet, its velocity is v1. When it is farthest distance from the planet, its velocity is v2. So here, there is no external torque acting on the system, so that angular momentum is conserved. So we use here m1 v1 r1 is equal to m2 v2 r2. Here m1 is mass of the satellite, m into v1 its velocity when it is closer to the planet is v1, and the closest distance is nothing but r1. m2 means that is the mass of the satellite, that is m, and v2 its velocity v2, and this is r2. So here m into When the satellite is near to the planet, its velocity is more, 6 times greater than when it is farthest distance from the planet. 6v into r1 is equal to m into v2. This is v. When the planet is moving away from when the satellite is moving away from the planet, its velocity is v. Then when it is come very close to the planet, its velocity is 6 times of previous velocity into r2. So here mv cancel. So the ratio of closest and farthest points r1 by r2 is equal to, that is equal to 1 by 6. Okay, this is our answer. Answer is 3. Answer is 3. Discuss another question. An electron is moving along a positive x direction with a velocity 6 into 10 to the power of 6 meter per second. The velocity how much? 6 into 10 to the power of 10 to the power of 6 meter per second. It enters into a region of uniform electric field 300 volt per centimeter, pointing along y direction. The magnitude and direction of the magnetic field set up in this region such that the electron keeps moving along the x direction will be, So here this electron is moving along x direction with velocity v I cap. Now the electric field is along y direction, along plus y direction. Electric field is. The magnitude and direction of the magnetic field set up in this region such that the electron keeps moving along x direction. That means there is no deflection of the electron. Okay. So whenever the electron is moving along x direction, the force acting on the electron is always opposite to the electric force is acting opposite to the direction of electric field. This is electric force. To keep the motion of the electron along x-axis, there is a magnetic force is acting exactly opposite to the electric field along y direction. This is F magnetic force. F magnetic force. Then only the electron is moving along x direction if these two forces are equal. F magnetic force is equal to F electric force. F magnetic force is nothing but EVB. That is equal to F electric force is nothing but E into E. Okay, E cancel here. Now we want to find out what B is equal to. E by V. B is equal to E by V. So here electric field is given 300 volt per centimeter. 300 volt, convert centimeter to meters, 10 to the power of minus 2. 3 into 10 to the power of 4 volt per meter. And what is velocity here? Velocity is nothing but how much velocity it is moving. V is equal to 6 into 10 to the power of 6 meter per second. 6 into 10 to the power of 6 meter per second. Now B is equal to what we write here, 3 into 10 to the power of 4 by 6 into 10 to the power of 6. That is equal to 3 into 10 square divided by 6. So B is equal to 1 by 2 into 10 square. So 0.5 into 10 square, that is equal to here. This is 10 to the power of minus 2. That is equal to 5 into 10 to the power of minus 3. 5 into 10 to the power of minus 3. This is not 3 into 10 square here. This is 3 by 6 into 10 square. So here 0.5 10 to the power of minus 2, that is equal to 5 into 10 to the power of minus 3 Tesla. Now the direction of magnetic field. We know that F is equal to Q into V bar cross V bar, the magnetic force. So magnetic force is acting along y direction, so that this is J bar is equal to what we write here, Q into electron is moving along x direction, I cross okay, I cross, so this is definitely K, I cross K. So I cross K is equal to how much here? So here so I cross K is equal to I cross V bar cross V bar here. I cross K is equal to minus J. So now we are going to find out the force acting on the now we are going to find out the direction of a magnetic field here. The direction of magnetic field means here from right hand thumb rule, here this is the direction of flow of charge, and this thumb indicates the force acting on the positive charge, magnetic force acting on the positive charge vertically downwards. Okay, V bar cross V bar. Assume that magnetic field is towards the positive z axis. Then what happens? The force acting on the positive charge is vertically downward. For electron, it is vertically upward. So our direction of magnetic field is along positive direction. So direction of magnetic field is along positive z direction. Okay, right.